So having reached the design challenge stage of the student T-book, what you have noticed is that there is a clear and evident shift from the study of the scientific principles related to the MMS mission to that of the engineering and design exercises that have to go into building a satellite that's able to carry the scientific equipment into space. So your students are going to be asked to design a three-dimensional shape that is going to be able to meet really three criteria. The three criteria are they going to be able to be sustainable? And by sustainable, we mean, are they going to be able to absorb or maximize the absorption of the sun's energy through the solar panels that are going to be affixed to the outside of their three-dimensional shape in order to sustain the satellite? Are they going to be able to fit inside of the rocket? And by fitting inside, what we mean is, can we take the shapes, stack them, and fit them inside of a simulated rocket vessel, that of being a simple chip can? And finally, when rotated in space, are they designed in such a way that the booms of the satellite are going to be able to hold the sensors far enough away from one another to measure what they are going to need to explore? So at the end, or if you take a look at the supplies listed in the first design challenges, it references the end of the T-book. And at the end of the T-book, there is a reference to some fabrication equipment, and that equipment is actually software. Now, the reason why we refer to software, certainly we could have our students use styrofoam blocks or planter foam to be able to carve out three-dimensional shapes. Besides the safety concerns that come into play when having students use objects that are relatively sharp to cut those three-dimensional shapes, the consistency from one shape to the next is almost impossible to achieve because each of them would be created independently from one another. So using three-dimensional software takes the design challenge of safety as well as consistency out of the picture and allows your students to use software, modeling software, to create printable and foldable shapes. If your students have used Google SketchUp in the past to create three-dimensional objects, they will be really familiar with the software design of Fab Labs Model Maker. The toolbars are very similar in terms of how they are able to create, stretch, expand, zoom in, zoom out, all of the different features and tools of creating the dimension and the shape of the three-dimensional object that they hope to achieve. The reference at the end of the T-book will take you to the Model Maker tutorials that are located on the maketolearn.org website. We are not going to take the time now to go through each of these, as you'll be able to do that on your own. So instead, what I'm going to do is share with you just some of the practical considerations that you may have to think about when having your students go through and create this part of the experiment, or this part of the design. The Model Maker software itself is a free download. However, there's a catch. It's a free trial download. That means that you are going to have to make a purchase if you're going to use that software in your classroom. And the price of the software is not necessarily cheap, depending on what it is that your school budget allows. You're looking at probably close to $80 to $100 US dollars for each license of the software. Now, it is functional. It's very practical to have students create their three-dimensional space digitally, and as you can see on cardstock or some type of rigid paper, your students can then quickly and easily print out those shapes. If, as I've already mentioned, your students are already familiar with Google SketchUp, there's some plugins that are available, one of them being Wavy, that is able to take your Google SketchUp software design, shape design, and turn it into two-dimensional, printable, cuttable, trimmable, foldable. And you'll notice here that the educational pricing is $80 per license that's renewed or has to be renewed annually. And certainly for the hobbyist, which the licensing perhaps would be fine for you to use in your class, you're looking at only about $20 US for each of those licenses. Okay, but obviously there may be some developmental barriers to this. Students in your class may not be able to necessarily use, or you may not have the time during your class time to be able to dedicate to them learning modeling software and then actually printing out the materials, or even purchasing the software to print out the materials and fold. So another option that's out there for you to consider is having students really research different types of three-dimensional shapes. And then instead of having them design them in the three-dimensional modeling software, essentially Googling what it is that they would like to see. So as an example, I've simply typed printable octagonal prism pattern. You can substitute anything you want in here. And notice one of the first hits that we see here in our Google image search is a printable paper model of an octagonal prism. Obviously, I could do the same thing here if I want a hectagonal prism. Okay, and the same objects appear. And certainly if your students want to go for just a simple cube pattern, that's an easy Google search as well. So simply adding the printable and the pattern as well as the shape that they would like to find allows them to perhaps have a happy medium between the full-blown 3D modeling software and that of going all the way back to the analog of having to carve or make shapes out of clay. This gives them some way to be able to pick a shape that they want to analyze and assess, but do so in a way that might be a little more cost effective or also might be a little more developmentally appropriate for your students. So hopefully this hint of using the modeling software all the way down to using Google SketchUp plugins, all the way down to using a simple Google search to find already pre-created printable patterns helps you decide what's the best for your context to enter the design challenges for your students.